Ferrari's confirmation that their 2026 Challenger will be named the SF26 may appear on the surface like a routine administrative announcement. In reality, it represents one of the most revealing moments in Maranello's recent history. This is Ferrari publicly closing the door on a failed concept and attaching their identity to a completely new technical vision. The SF26 is not simply the next car in a sequence. It is Ferrari admitting that the SF25 was structurally flawed and that nothing short of a full reset could restore competitiveness in a radically changing Formula One landscape. The emotional and competitive backdrop to this announcement cannot be ignored. Ferrari entered 2025 with momentum, credibility, and genuine belief after narrowly missing the 2024 Constructors' Championship. 12 months later, that belief had evaporated. 0 wins, a distant fourth place, and a points deficit exceeding 430 points exposed not a bad season, but a broken technical philosophy. The SF25 was a car that demanded perfection to function, and Formula One does not reward concepts that collapse the moment conditions deviate from the ideal. From a performance perspective, the numbers were unforgiving. Charles Leclerc's 7 podiums across a 24-race season represented a dramatic underachievement for a driver in his prime. Lewis Hamilton's absence from the podium for an entire season was unprecedented in his career. These were not isolated anomalies. They were symptoms of a car whose ride height sensitivity, plank wear, and narrow setup window turned every race weekend into a defensive exercise rather than a competitive one. The SF26 exists because Ferrari finally accepted that the problem was not optimization but architecture. This admission is crucial when viewed through the lens of the 20,126 regulations, which represent the most disruptive technical overhaul since 2014. Cars will be smaller, lighter, and far more complex to drive. Power units will deliver 50% of their output electrically. Fuels will be fully sustainable, and active aerodynamics will introduce constant shifts in load balance and efficiency throughout every lap. In this environment, Ferrari appear to have understood that extreme concepts with razor-thin operating windows will be punished more harshly than ever. Active aerodynamics amplify instability. If the mechanical platform is not robust, energy deployment becomes unpredictable if combustion efficiency fluctuates. The SF26 is therefore being conceived not as the fastest possible car in ideal conditions, but as one that remains exploitable across changing loads, tire states, and aerodynamic modes. One of the clearest indicators of this new thinking is the expected adoption of pushrod suspension at both the front and rear. This would mark Ferrari's first rear pushrod configuration since 2010, and it is a deeply strategic choice. Pushrod layouts offer greater internal packaging freedom, lower unsprung mass around the gearbox, and improved control over ride height sensitivity. In simple terms, it allows Ferrari to stabilize the car mechanically rather than chasing balance through aerodynamic compromises. This change directly addresses the SF25's defining weakness. Last season, Ferrari were forced into conservative ride heights to protect the plank, sacrificing downforce and tire performance before the race even began. With the SF26, the suspension philosophy aims to tolerate reality rather than fight it. Car that remains legal and stable across a wider range of conditions unlocks performance that cannot be accessed through peak figures alone. The power unit concept reinforces this philosophy. Ferrari's decision to commit to steel alloy cylinder heads is arguably the boldest engineering choice of the entire project. Aluminium has long been the default material due to weight advantages, but under the 2026 rules, absolute lightness is no longer the dominant factor, minimum power unit weight rising from 120 kg to 150 kg. Ferrari have prioritized thermal stability and combustion efficiency over marginal mass savings. Steel allows Ferrari to operate combustion chambers at pressures and temperatures previously considered unviable across race distance. This directly improves thermal efficiency, meaning more usable energy is extracted from each ignition event. Under a formula where energy deployment limits dictate lap time potential, even small gains in efficiency compound significantly over a race. Ferrari are chasing repeatable performance, not fragile peaks. This engine architecture also supports Ferrari's broader packaging strategy. Improved combustion efficiency reduces cooling demands, enabling smaller radiators and tighter bodywork that has profound aerodynamic implications. A narrower rear end improves airflow to the diffuser, reduces drag, and enhances stability under active aero transitions. The engine therefore becomes an enabler of performance rather than a constraint. Bar have complemented this with a new, more compact battery system designed to improve energy density and reduce packaging volume. In 2025, Ferrari often struggled with inconsistent energy deployment, affecting braking feel and rear stability. A refined battery architecture allows smoother transitions between harvesting and deployment, improving drivability and reducing tyre stress, especially on corner exit. Aerodynamically, the SF26 is expected to lean towards efficiency rather than extreme downforce. Active aero means that balance must be preserved as the car shifts between drag reduction and high load states. Ferrari appear to be prioritizing consistency of airflow and platform stability. Lessons reinforced by McLaren's recent success and Ferrari's own failures when wind tunnel gains collapsed on track. Driver interaction with the car has also been fundamentally rethought. The cockpit, steering wheel, and control interfaces are being redesigned to manage the cognitive load imposed by 2026. Drivers will need to manage energy deployment, recovery, brake-by-wire behavior, and aerodynamic modes continuously. Ferrari's response has been simplification without loss of authority, reducing mental friction at speed. Lewis Hamilton's influence here is significant. His experience within Mercedes's highly integrated systems has shaped Ferrari's approach to driver ergonomics and information flow. Hamilton thrives when feedback is clean and predictable, and the SF26 is being designed to restore that connection after a year where the SF25 consistently undermined his confidence. Charles Leclerc benefits from this philosophy in a different way. His strength lies in rhythm, consistency, and tyre management over long stints. Car that operates within a wider window with smoother mechanical and aerodynamic behavior aligns perfectly with his skill set. Over a season, this consistency often proves more decisive than peak qualifying pace. Ferrari's testing strategy is perhaps the clearest indicator that this reset is being taken seriously at an organizational level, not just a technical one. The launch spec SF26, scheduled to run in Barcelona, has been deliberately stripped of any pressure to perform on the stopwatch. Ferrari are treating those first days not as a competitive benchmark, but as a stress test for assumptions. Mileage accumulation, systems integration, and data correlation between simulator, CFD, wind tunnel, and real-world behavior are the priorities. This is a direct response to 2025, where early inconsistencies between simulation and track behavior left Ferrari chasing problems they never fully understood. What stands out is how disciplined this approach is. Ferrari have accepted that a car which looks fast but behaves unpredictably is useless under modern regulations. Barcelona is about verifying that the SF26 behaves exactly as expected across different ride heights, energy modes, and aerodynamic states. Only when that trust is established will Ferrari allow themselves to explore the upper limits of performance. It is a fundamentally different mindset to the one that defined previous Ferrari projects, where optimism often outpaced validation. The transition to a B-Spec for Bahrain is equally revealing. Rather than panicking into early upgrades or reacting to competitors' lap times, Ferrari have defined a clear development sequence. The Bahrain version is designed to layer performance on top of a stable foundation, not to correct structural weaknesses. This distinction matters enormously. Too often in the past, Ferrari upgrades have been reactive patches rather than logical evolutions. The SF26 program suggests a team finally willing to delay gratification in order to protect the season as a whole. I think that the most important thing Ferrari have revealed about the SF26 is not a specific component, material choice, or aerodynamic trick, but intent. Everything about this project points towards alignment. Mechanical design supports aerodynamic stability. Aerodynamics reduce energy demand. Reduced energy demand improves deployment flexibility. That flexibility feeds into strategy, tire management, and driver confidence.